Alrighty, here we go. We're going to do this practice test. The first question is to draw an angle in standard position with measure 120 degrees. What I think I should do here is draw a unit circle. I suppose you could try to do it without doing that, but I don't think that's what I should do. I think I should draw a unit circle. So let me go ahead and do that and then find 120 degrees on the unit circle. So, all right. I suppose I could have done that earlier, but made this first. Okay. First of all, here on the left is 0 degrees and here's 180 degrees. And if we do a little calculation of 180 minus 120, that makes 60. Okay, so when we open up our angle, we go counterclockwise, and up above here is 90 degrees, and so 120 is between 90 and 180. Well, the difference between our terminal side of the angle and 180 is 6 degrees, which I'm showing here. But that means, let me change colors, I suppose, that I have this angle here is 120 degrees. And maybe make this even brighter, that I have this angle like that. So that solves that problem. And let me actually just copy and paste. First, I'll make this even better by labeling this X and this Y here. So I'm going to copy and paste for the next problem where we have something very similar, except for this next one, it's going to be in radians. So we have to adjust things a bit for radians. So let me erase that. And when I have radians, I have 0 over where I'm showing that. And then here's pi. Well, we're looking at 6 pi. Well, pi is 6, so I just go 1/6 more to get 7/6 pi. And so my method, which is the one that's encouraged by just about all the textbook authors and so forth, is that I refer to the x-axis. So I refer to the x-axis and I look at the angle that is formed between the x-axis and my terminal side, and that's called the reference angle. And that is pi over 6, because at pi I have 6/6, and then I just add 1 pi over 6 and I get 7/6. Now, we're going down to a sort of a different problem where I'm going to refer to this picture at the right and find the arc length. Now, what is the arc length? The arc length is literally the length of that red arc there. So that red piece there is an arc. And what I use is a formula. Just we're going to use a formula. And so what's the formula? The formula for arc length is S equals R theta. Theta is in radians. In this particular problem, theta is pi over 6 radians. And also we see that the radius is 5. So S is therefore 5 times pi over 6. And it's not really that much of a problem here, except all it's saying is, hey, do you know that formula? I don't think there's much more to that. Okay. Then next, we're going to find the area of the sector. The region which forms the sector is highlighted in orange. The area of the sector is given by a formula, which I'm all of a sudden wondering, do I know the formula? I think I do. 1/2 r squared theta. Now, one of the ways I can sort of check myself if I'm getting this right is, what if theta is equal to 2 pi? That's the whole circle then. If I have the whole circle, theta is 2 pi, and I'd have 1/2 r squared times 2 pi, and that makes pi r squared. That makes the area of the circle. Okay, but back to this problem here. Once again, I'll just write it down again, but I don't think I need to, but I will anyway. I'm going to write down the given from the picture. It's a little small, but r is 5 and theta is pi over 6. So therefore, a equals 1/2 5 squared times pi over 6. Now it's up to me to get this wrong by just multiplying wrong, I guess. 5 squared is 25, pi over 6. Okay, I'm going to multiply the 25 times pi, that's the numerator, and then I'm going to multiply 2 times 6, and I get 12. There's no units given, so it might make the whole problem more interesting if I made up these problems, but maybe it would have been better if I had said that that's 5 inches or something like that. And then I could say it's, square inches or something. All right, okay, that's one page of this practice test, and I'm going to stop the video now, and then I'll have another video with the next page.